Bismillahirrahmanirrahim. Assalamu alaikum dear students. I hope you all are enjoying good health. This is the 13th lecture of research methodology. In the previous lecture we discussed about entering and editing mathematics in the scientific workplace, formatting the documents with tags and typesetting the document. We also discussed how to write equations and how to label the equations in the text. Now in this lecture we will discuss some basics of SWP and computing and plotting in the scientific workplace. As in the previous lecture, we see that the scientific workplace window appears like this window. The program window is your workplace. Take a moment to familiarize yourself with the window, its menus, and some commonly used toolbars as are shown in this figure. Here this is the title bar, this is the menu bar, this is the standard toolbar, and this is the math template, this is compute toolbar, this is history toolbar, this is stop button, and this is symbol cache, and this is the typeset toolbar. And here we start our writing the document, and this is document window, this is program window, and this is the tag toolbar. In the previous lecture we discussed some tags from this bar, and this is the status bar, this is fragment toolbar, and this is remove item tag button. From this button we remove tags which are applied to the text. So this is the basic window of the scientific workplace. In the standard toolbar you will see these buttons: new, open, save, open location, print, preview, spelling check, cut, copy, paste, undo, properties, show, hide, non-printing, toggle text or math. This button is used to convert the text into mathematics and to convert mathematics into text. This button is used to draw a table, and this is the zoom factor from which we can zoom the document. Other toolbars are available in the view menu. To display or hide a toolbar, from the view menu choose toolbars. In the toolbar dialog box, check the box next to each toolbar you want to display and uncheck the box next to each toolbar that you want to hide. For example, this is the scientific workplace. From view menu you can choose toolbars option, and by selecting this option the box of toolbars appears, and from here you can choose the toolbars of your interest. In the previous lecture we discussed in detail about opening a document, opening a new document, and opening an existing document, opening a sample research paper, or opening a sample thesis. We also discussed entering and editing text in the previous lecture. We also discussed to insert a table in the text. We also discussed entering and editing mathematics in the text. We also discussed to write equations and to label equations in the text. We have also discussed entering mathematical objects in the text. This toolbar is used to insert mathematical objects in the text. This is the symbol of fraction. This button is used to insert radical. This button is used to insert superscript. This button is used to insert subscript. This button is used to insert parentheses. This is for square brackets. This is for sum. This is for integral. This is unit name. This button is used to write the equation. These are operators. These are brackets. This button is used to insert matrix. This button is used to insert trigonometric functions. This is the binomial button. This button is used to insert label above the any alphabet. And this button is used to insert arrow or bar on any alphabet. For example, to enter a fraction on the math template toolbar, click this button, or from the insert menu choose fraction or press Ctrl F. On the screen you see this image and the math text toggle changes to this M. Type the numerator and then press tab. Type the denominator and then press spacebar. To enter a superscript or subscript, click T, or from the insert menu choose math to start mathematics. Type a variable. On the math templates toolbar, click this button or press Ctrl up or Ctrl 3 to enter the superscript. Or on the math template toolbar, click this button or press Ctrl down arrow to enter a subscript. Type the superscript or subscript and then press the space bar. To enter an expression in parentheses, on the math template toolbar, click this button. Type the expression. Notice that the parentheses are elastic. They expand horizontally and vertically as far as necessary to enclose the expression you enter. Press the space bar. To enter a matrix, on the Math Objects toolbar, click this button, or from Insert menu, click on Matrix. Set the number of rows and columns, the alignment and the baseline of the matrix. Choose the delimiters from the matrix if desired. Choose OK. Fill your matrix with mathematics, moving from cell to cell with the tab key or arrow key. Press the space bar to leave the matrix. Similarly, all other mathematical operations can be used. You can see in this guide. Now we discuss computing and plotting in scientific workplace. In the scientific workplace, you can perform basic and complex mathematical computations right in your document. You can use the computational engine to perform symbolic computations fundamental to algebra, trigonometry, and calculus, evaluating, factoring, combining, expanding, and simplifying terms and expressions containing integers, fractions, and real or complex numbers. You can also perform integration, differentiation, matrix and vector operations, standard deviations, and many other more complex computations involved in calculus, linear algebra, differential equations, and statistics. Scientific workplace don't include a computational engine. You can plot the results of your computations or use them to perform additional computations. You can plot additional items by dragging them onto an existing plot. You can build a series of expressions that show a step-by-step approach to a problem solution by computing in place, performing computations within an expression rather than on an entire expression. To try the sample computations in this chapter, display the math templates, math objects, compute, sample cache toolbars. Results may differ slightly depending on the default selected. To perform a computation or plot a graph, enter a mathematical expression. With the insertion point in or at the immediate right of the expression, choose the command you want to from compute menu or the compute toolbar. So this is the compute toolbar. While computations take place, the program displays a computational pointer. Then the program inserts the result in your document. Most computations are fast, but some take several times. Occasionally you may want to cancel a computation. To stop a computation, click this stop button or press Ctrl break. Evaluate and evaluate numerically. You can easily collect terms, find the sum or difference of polynomials, change a quotient to rational form, or raise a number to a power with the evaluate or evaluate numerically commands. When you evaluate an expression, the computational engine returns an exact or symbolic answer whenever appropriate and a numerical approximation otherwise. You can use the evaluate numerically command to force a numerical result for any evaluation. For example, you want to evaluate this expression 2.36 square root. Click this button. The program starts mathematics automatically. Type 2.36. Your screen shows the expression this. Then click on this button. The computational engine evaluates and you see this result, which is given in this box. Similarly, you can evaluate this expression 0.16 to the power minus 1. You have to choose this button. The program starts mathematics automatically. Type 0.16 in the parenthesis and press the space bar. Click on this button and type minus 1. Your screen shows this expression 0.16 to the power minus 1. Click on this button. The computational engine evaluates the expression as given in this box. This button is for simple evaluation and this button is for the evaluation numerically. To evaluate numerically 936 divided by 14, you have to type this. Click T or from the insert menu choose math to start mathematics. Type 936, click on this button on the sample cache toolbar and type 14. Then click on this button which is for evaluate numerically. Your screen displays this result. Evaluate pi numerically. On the sample cache toolbar, click on this button, which is the button of pi, and then click on evaluate numerically button. The evaluation yields this result. Now you see how the results differ when you change the numerical accuracy with which the computational engine operates. From the tool menu, choose engine setup and choose the general tab. Change the setting from digits used in computations to 20 and choose OK. From the tools menu, choose computational setup and choose general tab. Change the settings from digits shown in results to 20 and choose OK. Press enter. Click pi and then click on this button. Then you see this result which shows the 20 decimal points. You can evaluate these expressions in the scientific workplace. This is your exercise. You should try yourself. Factor command. You can use factor command when you need to find the elements or quantities whose multiplication gives a center product or polynomial. For example, we want to factor this 12,345, this number. Click T, choose math to start mathematics, type this number. From the compute menu, choose factor. Your screen will show this result. 3 multiplied by 5 multiplied with 823. If you want to factor this expression x square minus y square, similar procedures will be adopted. Click T or from the insert menu choose math to start mathematics. Type x, click this button. This is for superscript. Then type 2 and then press spacebar. Then type minus y. Click on this button which is for superscript and then type 2. You will see x square minus y square. Then from compute menu choose factor. Your screen shows this result. x minus y into x plus y. Now you should try to factor these expressions yourself. In addition to combining the items in mathematical expressions, you can use the combine command to demonstrate the laws of exponents and the properties of logarithms. Combine sin x cos y plus cos x sin y. When you type this expression in scientific workplace and choose the combine option from the compute menu, you will see this result which is given in this box. So the result is sin x plus y. Similarly, you can combine this expression by choosing the combine operation from the compute menu, and the result is 10 to the power x plus y. We can also expand powers of polynomials or products of the polynomials by choosing the expand command as given in this example. Here sin 2x is expanded by choosing the expand command, and the result is 2 cos x sin x. Now simplify command. You can reduce expressions to standard form by collecting like terms in addition and cancelling common factors in division. When possible, computational engine performs indicator operations exactly or reduces them to lower level operations. Here this expression is simplified in this form. The result is 2a plus 6b. Moreover, this expression is simplified in this form. You should try yourself to simplify these expressions. Now, working with polynomials. Use the commands on the polynomials and calculus submenus to collect and order the terms in polynomials, divide polynomials, find roots, and write a rational expression as the sum of partial fractions. To collect the terms in this expression, we will use the command of collect by typing this expression in scientific workplace and choosing the collect command from compute menu, and the result is given in this box: x to the power 5 minus 7x square plus 11x minus 3. We can order the terms in the expression by choosing the sort command. We can write the partial fractions of this fraction by using the partial fraction command. We can also find the roots of the polynomial by using the roots command from the compute menu. You should try these exercises to collect, order, divide, or to find the roots of these polynomials. You should try yourself these expressions. To create 2D and 3D plots, we should have to use the plot command from the compute menu. For example, we want to plot x square. We should type x square and then click on this button from the compute menu. To plot x square, we should type x square in scientific workplace and then click on this button, or from the compute menu we will choose plot 2D and then choose rectangular. The computational engine plots the expression x square as given in this figure. Now we see that the plot of x square is given in this image, in this figure. To add the plot of x cube in this figure, we will just type x cube in SWP and drag it onto the plot. The computational engine replots by adding the new function, and the new image will be in this form. To plot ln x, we will type lnx in SWP and then click on this button. The plot will be shown in this form. To plot x square y cube, we will type x square y cube in SWP and then click on this button, which is the button for plot 3D, or we can choose from the compute menu the plot 3D and then choose rectangular. The computational engine plots the expression x square y cube as given in this figure. We can also perform matrix operations in SWP. First of all, we will write the matrix. For example, we want to find the transpose of this matrix. We will type the matrix by using the matrix button, and then we will choose from compute menu, and then from matrices menu we will choose transpose. The computational engine transposes the matrix as shown in this box. The transpose of this matrix is given here. We can also find the inverse of the matrix. First of all, we will type the matrix by using this button. After writing the matrix from the compute menu, we will choose matrices and then choose inverse. The computational engine inverts the matrix as shown in this box. You should try to perform these matrix operations yourself. We can also solve differential equations in SWP. For example, we want to compute dy over dx is equal to x. First of all, we will type this equation in SWP, and then from the compute menu we will choose solve ODE and then choose exact. The computational engine will give the result as shown in this box. The exact solution is 1 by 2x square plus c2. We can also find the solution of initial value problem. We have to type the problem in this form by using the matrix button, and then from the compute menu we will choose solve ODE and then choose exact. The result is shown in this box. You should try to compute these differential equations in SWP by yourself. Dear students, this is the end of today's lecture. In the next lecture we will discuss typesetting the document and creating bibliographies and citations. Take care of yourself and your family. Allah Hafiz.